Next, we want to take on Dsss, or Direct Sequence Spread Spectrum. This was used by 802.11b and A, I believe. And the way it worked, it was also a spread spectrum. So the idea of all spread spectrum is to spread out the frequencies that we're using. And again, this is kind of a security thing, the reason that we did this. The idea of DSSS is if you want to send a bit, you generate 11 bits. And it looks like this for a 1. They're exactly the opposite for a 0. So this is called a chip code, by the way, sometimes called a Barker code. So let's say that I want to transmit a 1. Well, the device that actually goes into my transmitter before it goes there, I set up a device that generates for a 1. It generates 0011001111. It spreads that out. Now it's going to send each of these, this 0, this 1, and so on, over a different frequency. So now we've spread out that original, instead of one frequency or frequency hopping, where we just jumped here and then jumped here and then jumped here and then jumped down here and then jumped up here and jumped down here and so on. We're spreading it out now over an entire range of frequencies. And then once we get to the other end, we decode that back to the original 1 again. One nice thing about this is if several of these bits are corrupted, we can still mathematically put together what the 1 was, what the original bit was supposed to be. And at the same time, it made it very difficult for our enemies, primarily the Germans at the time, to decode all of this and figure it out. And so this was also a nice security feature. It didn't really slow things down because you're transmitting all these at the same time. So while it's not the fastest thing in the world, it turns out that it's much faster than you might think.